our last form of solving a system in two variables. We're going to dive directly into an example. 4x plus 6y equals negative 2. Negative 2x plus y equals negative 11. Now, on a problem like this one, substitution wouldn't be terrible. When you look at this problem, could you get one of the variables 100% by itself? Fairly easily. Yeah. This y is pretty easy to get alone. But sometimes it's not nice. And those times especially, it's good to have a different option. So the second option for solving requires that you have the two equations stacked on top of one another with all of its like terms and its equal sign. Starts there. Do I have x's over x, y's over y's, equal over equal, and constant over constant? Yes. Everything stacked is like terms, including the equal signs are in the same place. Once we have that, the next thing we want is we want one of the variables. Doesn't matter if it's x, doesn't matter if it's y. You want one of them to have numbers in front of them that are opposites. What are opposites? Positive and negative of the same thing. 5 and negative 5, 12 and negative 12. Those are opposites. Okay, I currently do not have that, but I'm allowed to adjust equations. Now, it does not matter if you get the y's to have opposite numbers or the x's. I personally am going to get the x's this time because if I wanted the y's to have opposite numbers, I'd be looking at the smaller one. What would I have to multiply by y? Versus multiplying by x to get the opposite? Just 3. Smaller number. I like smaller numbers. So, that's what I'm going to do. I'm going to take this equation, the entire equation, I'm going to multiply by 3. Now, as I do this, I tend to move left to right for the original thing. Okay, multiply that by 3, I get negative 6x. Multiply that by 3, I get 3y. Equals. Do not forget the constant. It's one of the most common mistakes I see is people forget to multiply that negative 11 by 3. Negative 33. Why do I get, what did I just do? Why did I multiply by 3? Let me try that again. What did we need to multiply by x to get the opposite number?
2.
Why did I say 3? Oh my goodness. In case you didn't know, teachers have those days too. Okay, we're going to multiply that by 2 because Benson needs a brain that works, apparently. This is going to be a negative 4x. This will be 2y, and this will be 22. I wondered why you guys got unusually quiet. It's okay when I make mistakes like that for you to just tell me I did something stupid.
I didn't even notice.
Okay, let's try that again. Now that we have that, I'm just going to pull this over so that it's stacked again. Now, the advantage of having opposites is when you add opposites, what do you get? 0. Negative 4x plus the positive 4x will cancel out. 6y plus 2y, 8y, equal to negative 2 plus a negative 22, negative 24. You will always get one of the variables to cancel out this way. You'll know how to solve basics. Y is negative 3. Am I done? Solution to a system has both an x and a y. Define the x. I plug back in. Does it matter if you plug into the first equation, the second equation, or the modified equation? No, you just got to make a choice, whichever looks easiest. Which looks easiest to you?
Bottom one.
Okay. Negative 2x plus, remember when you plug in, technically you're plugging it in parentheses. Sometimes that makes a difference, other times it does not. Does it make a difference here? No. Plus a negative is just minus. And we solve. I get that x is 4. What does that make our final answer? 4, negative 3. Remember, x, y, or if it's different variables, it goes in alphabetical order. A, B, M, N. Does this look familiar? It's called elimination. Got just a couple more examples. Three x plus 15y equals 3. 4x plus 10y equals 14. Is everything stacked the way we want it? Yeah. Are the numbers what we want? No. We need to get one of the variables to have the same numbers in front of it. Do you want to do the x's or the y's?
X's.
It really doesn't matter. You just got to make a choice. Who wants to do the x's? Who wants to get the y's the same? Of the people that voted, a few more people went with y. What are you noticing with 15 and 10? What can they both become? They can both divide by 5. We don't want divide. We want multiples of them. 30. I can turn them both into 30. Now, neither of them is currently 30. On the previous problem, we only had to multiply one equation to get opposite coefficients. Sometimes, you gotta multiply both. I'm gonna turn them both into 30, or more accurately, one of them into 30 and the other one into negative 30. How do I turn 15 into 30? Multiply by 2. Well, that one's 30. That means this one's negative 30. What do I multiply by 10 to get negative 30? Negative 3. Make sure you multiply everything through. 2 times 3x, 6x. 2 times 15y, 30y, equals 2 times 3, 6. Negative 3 times 4x. I heard there's x. I missed the rest of it. Negative 12. 10y times negative 3. negative 30y equals 14 times negative 3. Negative 42. The y's now have opposite coefficients. To get them to cancel out, I would then do what? Once I have opposites, you add. Be careful with your positives and negatives. What is 6 plus negative 12? Negative 6x. 30 plus negative 30 cancels. 6 plus negative 42? Negative 36. Now we solve for x. Divide by negative 6, and x is 6. Are we done? No, we need y. Which equation do you want to plug back into? The first one, the second one, or one of the modifieds? First one, sure. Doesn't matter first or second. I wouldn't do a modified. Those ones are bigger numbers. Make sure you're plugging back into the correct variable. It's another common mistake I see. People solve for x and plug it into y accidentally, or vice versa. Three times 6 is 18, plus 5y equals 3. Subtract the 18 and I get 15y equals negative 15. Divide by 15 and y is negative 1. Final answer? 6, negative 1. I got one final example and then I'm done with notes today. Is it stacked the way I want it? No, which means I gotta manipulate things before I even think about multiplying. The second problem has x, y equals constant. The first problem has x equals constant y. Easiest way would probably get the x, y equals constant because that's the general form that works out nicely. So yeah. Take the top equation and add 4y. Three x plus 4y is equal to 12. Now, they're in the right structure. Let's say I want to match my x's. Which equation am I multiplying by what? The first one or the second one is what I'm going to call them.
Second one.
Second one by negative 2. And because this one's hanging out over here, I'll just move it over here. I get negative 6x minus 8y equals negative 24. Now that they're opposites, I can add. That cancels, that cancels, that cancels. What am I actually left with?
0 equals 0.
0 equals 0. 0 equals 0 implies what's true?
Everything.
Not everything. I know what you mean, but it's technically not everything. There's infinitely many solutions. The answer is technically not everything, because the solutions do have to fit the structure of one of these equations, which they're essentially the same equation. But there is way too many solutions for us to do anything with.